So in short, what I was able to do was to use Python to read and write from CPOs from the framework, and then also use the Python wrapper to execute the ITM actors. And so here I give a short demonstration of these things in action for one actor, which is the equilibrium code CHEASE. Also, while I was here, I installed on the gateway a public version of OMFIT that anyone here can try. So all you need to do is go to my home directory, /u/orm, and then OMFIT. And you know, if everything works right, basically the framework should start. So and all of the environmental settings and everything should be set up for you from the get-go. So here, this is the environment that we're going to be working on. You guys attended the presentation from Brian, so I guess you're a bit familiar with the environment. So without any further ado, I'm just going to load the CHEASE module. So if I'm going to go to File, Import Module, here there are all of the modules that are in OMFIT, and one of these is this CHEASE ITM. And so if I hit return, we now have CHEASE ITM module inside of the OMFIT 3. And so here you can see that there is an actor, there are some scripts, there are some plotting scripts, there are some GUIs, some library things, if it wakes up. So the easy way of using OMFIT modules is to use the graphical user interface. So here what we do, we just select the module, we hit return, and we get presented with the interface. So here we have to specify the device, the shot, the time. We use milliseconds, so you know, just add 3 zeros to what you're used to. The run, I forgot, 897. I forgot what 897. 897 maybe. My username, or actually we can take data from someone else. Whoops, my computer is doing a lot. So yeah, okay. The occurrence, and then when we're ready, we just hit setup CHEASE, and basically this will go and fetches the CPO from the UAL, and then loads it into the OMFIT data structure. And so here you can see that under the inputs, now we have the CPO. Okay, so this is a CPO of type equilibrium, and you can see that now it's extremely easy to see what's inside of the CPO. So here, for example, we have all of the 1D profiles. For example, we can look at, I don't know, the pressure. If we just hit return, we see the pressure.
It's a bit slow.
Yeah, it's slow, so...
You are recording.
Oh, wow, it's very slow. Okay, I'll speak slowly too. Also, you know, because this is an equilibrium actor, we can feed in, we can program the instructions to present the most important information to us just by selecting it and hitting return on it. And so what this does is just, you know, for every type of CPO, you know, we can define a set of instructions that allows us to present something like this, just at the click of a button. Also, what this button setup CHEASE did was it went and took all of the code parameters which are recorded into the CPO, and for that run, that specific run, and it interpreted them so that now under the actor code parameters, we can see what are the code, what are the parameters which were used to run that specific run. And so it's easy to browse and look at things. Now we haven't run CHEASE yet, so so also here you see this is the GUI. The GUI, as you saw, kind of changes itself depending on the information which is in the OMFIT 3. So now that we have the inputs and the code parameters, right, we want to maybe set up and change things. So for example, if we go under settings, now we can see that what is basically in the code parameters, now it can be edited here in the GUI. And also things like, so there are complex things here that can be edited, and we can, for example, pick more complex options that basically set multiple switches in the code parameters at once. Okay, so and this graphical interface is automatically generated using the schemas that are available for every actor. So really, the code to generate this graphical user interface is very short, and it can be used for any actor. Once we have that, we can, for example, run CHEASE. So if I hit here, if I press on the Run CHEASE button, just CHEASE runs. And now, we can, for example, plot, the output. And actually, we can. Sorry, let me do this. We can compare the output of the new run and of the old run, and they should be basically identical, which is the case. We can have more fun now. We can, for example, take any of the one-dimensional profiles, and we can modify it by any expression. So let's take, for example, the pressure, which here is y, and we can multiply it by 5. So now we see what is the value of the original pressure versus the original the value of the modified pressure. And now, if we run CHEASE again, right, we would expect a change in the equilibrium. The Shafranov shift should have increased. Okay. So again, I can press. I could compare the outputs here, or obviously I can go in the OMFIT 3. Right, and I can, for example, click the new one, and click the old one. Okay, put them side by side, or I could compare them, and you can see that the Shafranov shift indeed has increased. Okay. Other fun things that we can do is, for example, we can decide to modify the plasma boundary. So this is something that we use, for example, for EFITs, and here we can take our. Come on, it is very slow. Come on. So we can, for example, hey. I think it's just low. Come on.
If the Chromecast is...
Well, if it's slow on his screen, that shouldn't matter.
It's also slow on my screen.
So I have seen a delay between what's on my screen and that.
Yeah,
but I think the problem is...
the gateway and the connection.
No.
Oh no, okay, okay.
Used to say
All right.
record there.
It woke up. All right. So we can, for example, remove the upper null, put a lower null. We can change, I don't know, let's change the triangularity. Let's make a funny shape. Come on. Okay. I don't know, something like that. Come on. There you go. Something like that, right? That's the perfect plasma. And once we have it, we just say run CHEASE again, and now, we have a new boundary. So this is, for example, a tool that someone could use for designing a new shot on jet. So now if we want to plot the equilibrium, there you go, here's a plasma. We can even do, now, this is playing via the GUI, but now you're in Python and you're in OMFIT, so what you can do is almost limitless. So we can, for example, take, make a sequence of equilibria and change the pressure and just save how things change as we change the pressure. So to do this, we can just pick our pressure here. Okay, so let me just make a bit more space, and we call this pressure. And now we can make a loop for k in range. Oh, it's very slow. Okay, so for 5 times, right? We're gonna take this pressure, and we're gonna divide it by 2. Okay, and then every time, what do we want to do? We want to run CHEASE. Okay, and then we want to take the output, and we want to put it somewhere else. So let's make results. Okay. Now this OMFIT results. Let's it's just a container. Okay. So actually, I think something like this, and then maybe we want to plot how things are changing at every step. Okay. So let's see. Yeah, we make the thing, we divide it by 2, we run, we put it aside, and we plot. Okay. So if I run this, we just have to sit back and generate a sequence of equilibria with varying pressure. So this is something that obviously it's very easy to do with the scripting. So you see your pressure is changing and your shift is moving. And now once you have that, if we had, for example, a stability actor, we could just take those CPOs, put them in, feed them. Yeah. And this is done. Maybe I should have left it up there, but so now we can go back to the GUI, and so each one of these, the CPOs, if I wanted, for example, to save each one of these in the I call it 3, in the UAL, you could simply take it and say, dot put, and then we could change the occurrence equal k, for example. Shot equal, I don't know, and so on. And this would, save the result of our iterations this way. Or we can do this by the GUI. This will just save the last one that I have here. We can say occurrence 1 for this shot, and then we just save it. Yeah. So if you want a triangular equilibrium, you can access this shot and run and occurrence. And the summary of what I've done is here. If you in this web link within the OMFIT 3, if you press spacebar, you should open up Mozilla, and this will take you to a Google Doc which documents the work that I've done, and some bugs and how I compile things and so on. If you want to reproduce it. So in principle, all this is very generic, and making this for any other ITM actors is extremely easy at this point. So it's really basically a matter of having these Python wrappers working properly, and then I think we can leverage this system to to use it.
How generic is your XSD rendering? Because I think there are some.
So the you mean the GUI?
Yeah, because I think when we display the code params in the Kepler workflow, some of the more advanced features depends on using the JAX content.
I don't know. It may be wrong. So this is how it's done now. So this is a recursive script which does all of the parsing and everything. So you have entries. You have basically in here is where you call yourself to be recursive. These are the choice options. So where you have multiple choices, and that's it. So this is the code that does the parsing of that and the rendering. So one of the advantages of OMFIT, I think, is really the API simplifies the generation of these graphical interfaces. And actually, I honestly don't particularly like this kind of interface here because it exposes everything, and is not smart in the sense that, for example, if I choose here to use an analytical boundary, right? The GUI should automatically show me, the geometric parameters.
So there are some.
And it should automatically hide them if it's not, So having that kind of logic,
so there are some actors who has XSDs with features like that.
Okay.
But they depend. This is what I'm asking. But I do think they depend on the rendering of those through the JAX content.
Right. So in OMFIT, what we do is if it's very easy to generate the graphical interface. So in a way, I would be almost more keen on using so let's say that we want to change this parameter and add it to the OMFIT GUI. Let's put it at the top. So here we just say OMFITX.entry. We have to tell it what we want to edit. So this long thing, and then we have to tell it something that the user can understand, like number of pp function, which I don't know what it is, but something like that. And that's it. So you tell it what you want to edit, and yeah, there you go. That's the GUI. So it's also you can have complex logic extremely easily coded. So here, for example, I say if there are the inputs, show the rest of the GUI. If there are the outputs, show this part of the GUI. So it's basically functional programming, for GUIs. So yeah, this we can go on. Procedural, correct. Sorry.
No Haskell.
Can you show some examples where you compare different signals that have nothing to do with CPUs?
Comparisons?
So you mean plotting different things on the same graph on values?
Sure. So, well, let's see. Oh yeah, we have the results, right? So here, for example, we can take I don't know. I keep P prime or what? Q profile. There you go. That way we don't always pull out the pressure. And then we can do the same for 1D. And then we have the Q profile again, and we just hit instead of return, shift return to overplot it. There you go. And then we can also do you know, the same. I guess there should be a row. Yeah, we can go plot, set this as the x, and then let's plot, I don't know, j parallel. So now this is as a function of row toroidal instead of array element. I guess there should be somewhere, let's see, well, yeah, here is for the boundary, you know, R and Z. But yeah, or maybe profile 2D. Yeah, so this is psi. Whoopsie.
Then you have
Oh yeah, yeah, sorry, because I was trying to use.
you have preloaded all this data in the window.
What is it?
You have preloaded all this data in
The data is in memory.
Yeah.
But the data is only loaded if I access the thing. So so let's oh yeah.
Do you have? I'm sure you have that. Do you have some GUI that says I want this kind of data for various list of entries or pulses? And
so
I fetch them and
so let's do like this. So here I have these are, you know, a subset of the things that OMFIT can read. And so there is an ITM CPO. So we can get OMFIT CPO of type equilibrium from this shot run, blah blah blah. Actually, if we say none, and we put it under, I don't know, CPOs. So now here I have all of the CPOs, and then, you know, we can look. So these are not loaded.
Okay, let me do it differently. I have a list of 10 pulses. I want to see the plasma current for the 10 pulses.
Okay, so the plasma current is where? So let me.
I don't ask about CPU.
Ah, in general. Okay. So yeah. So if you go, for example, import module, and then you say scope. So there is a scope module for, you know, looking at experimental data. Yeah, right. It doesn't have jet. So let me. It doesn't like jet. So here we say D3D. Okay. So here we can restore this group, put a D3D shot, you know, sometime if you're interested in. And then these are the signals that we're going to be plotting. And then we say plot. So this is a bit complicated because now the D3D data is behind a firewall. So we have to open a SSH tunnel automatically, and then connect to the MDS Plus server there, and go fetch the signals and, you know, bring in the data and plot. So actually but once the tunnel is open, you know, we're okay for you know, for connecting to that machine. So this is going to take a second. Obviously, if you're local, you know, you don't have to do that. So if I was on you know, on D3D, I wouldn't have to pay the price. So yeah, here it's, you know, loading the data, and then it will plot it. It's just slow because it's via SSH. So one thing that I would like to do is have the same way, you know, that OMFIT is running on gateway, and we're accessing MDS Plus data on D3D. I would like to have, you know, OMFIT at D3D accessing CPOs on gateway. Yeah, there you go. So this is a D3D shot. So, you know, you can see, we can look at the, for example, the ramp up phase, and you know, how the different things work. And so, and here I have this thing which is annoying. Sorry. So, and here, oh no, yeah. Let me, yeah, just reduce it. here you can type TDI functions, or you can type just MDS plus locations and access that.
Can you overclock?
Oh yeah. Let me add let me
Another shot.
yeah, let me add a shot.
Or another-
Yeah, let me add a shot. I don't know if this shot exists. Oh shoot. Yeah. Ah, it's okay.
Feels like
Hmm?
it's really
Yeah, no, you asked for overplotting, not yeah. But yeah, no, it can, and then actually once it gets the data, it's buffered, so it will be fast. Anyways, yeah. So maybe the question that I have for you is how much you're willing to support, at least the Python interfaces.
What would this involve? That was a very open-ended question.
They are supported.
Well, actually, just if you look at the document, there were plenty of bugs and things that we had to figure out this week. So,
but not in the Python UAL.
Not in the Python UL, but in the Python wrapper and the Fortran wrapper using Python and C, we figured.
One issue is always building Python. Supposed to have a simple way. There you need to do a little hack to build the Python with your Python against existing UAL.
So what I would like is to have, let's start with the gateway, and I would like to have a public, version of gateway with all the Python actors working. That way, my work would be or anybody who's interested work would be, basically filling in the OMFIT part. So I think that that would be something reasonable, no?
Do you mean public gateway?
Like you saw now, if you go, there and you type OMFIT, it works.
Yeah.
Now I want that somehow, if I want the Python actor, it works. You give me an include path to my Python, and those functions run Python actors. No install, no. Right? How hard it is?
They are, but they are completely uninteresting.
No, but
They are generated.
Warsaw tested, so we found some bugs.
Yeah. So
they will be
there's
corrected.
two bugs that have been fixed. One by Bartek on C2K side, one by myself and by UAL.
Mm-hmm.
Part of that, there's still one bug hanging, which we should look into.
But once that is done, we should have the public version being able to.
But I'm still not sure what public would be.
That I don't have to compile these actors myself.
You mean the Kaplan installation?
Yeah, like
But I thought they were already all compiled.
But with with bugs. runs With there's a bugs. Python
Right.
interface.
With bugs. So these
Okay.
Python wrappers, they have bugs.
So perhaps there are already those actors in the central installation.
Okay. I mean, if it's already done, that's great.
But they are not working.
Okay.
Well, they would have been done with the version of
Okay. So
FCDPy that was running when that version of
Yeah.
Kepler was generated.
okay. All right.
Exactly.
So we can.
If FTP contains all of these fixes, I believe.
We should be able. We are in business. Okay. And then the other question is anyone else interested in learning this? Because this is the showcase, but it would be great if someone on your side was interested in learning and actually using this. Is anyone doing, stability after running an equilibrium code? Is anyone,
Rudy is doing that, so you
That's
need to book a flight to listen.
No, and I don't want to force feed people. If they have things working their way, that's fantastic, It's
You mentioned one example. The person who's doing that is Rui. Book a flight to Lisbon.
Okay.
And have a chat.
Well, so or maybe have Rui come to GA. I don't know.
But it's just one example, one person. But I think the main added feature we have is the interactivity, which comes from Python and OMFIT having graphical interface. So having a single actor, you can just run it, you can directly explore the data, change the data, run it again. You don't have to go through Kepler, UAL, saving, reading. It just saves you a lot of time and gives you a lot of flexibility. You can even then, of course, do simple workflows, try to couple two actors. This is still easier compared to Kepler. You still have the interactivity, which is really beneficial for doing this kind of development. And only after that, I think we should go to complex workflows, which then can be done perhaps in Kepler or whatever. But for development, I think this is a tool we've been missing since
For development,
beginning of
for
the
just
time.
viewing, having quick access to look at things. Very convenient.
So we have a number of workflows which are at the level of UL init, actor 1, actor 2, UL collector.
Now the question is how.
And I mean,
Anybody who's developing a new actor and trying to get it working is doing precisely that. The guy who was sitting next to me earlier, David, is taking UL init, taking data, putting into his bit 1 actor, taking output and putting into UL collector.
Okay.
And trying to understand why things aren't working.
So basically the same thing that I've done with CHEASE, but with his own thing. Right. So maybe tomorrow we can have his
no, this room is full of people who are doing that or who have been doing that.
Just to run one code.
Yes.
Right.
Yeah.
So
or
that
in some cases, run 2 codes.
okay.
Because we have a number of deliverables which are couple these 2 codes together and demonstrate that it works.
Right. So the coupling could also be done.
The coupling in this case is output from this goes input to this, and it's really just the data flow.
Right.
And that presumably could be
So-
done through.
Oh yeah. I mean if I duplicate this actor, let's see. If we duplicate this actor, we call it actor 1. And we copy the output of one into the input of the other, and we run it. That's coupled. But it takes me about that much. So we could have a CHEASE ITM. We could have, I don't know what stability actors you use, but we could have the 2 of them and just take the CPU, put it in, and get up. So this is through OMFIT. If it's very complicated workflow, maybe you want to do something like with the WOP framework that Jakub has, where you don't have to move data from to disk. You just stay everything in memory. But again, I think these are things that we can face when when the problem arises.
But there's no one single approach, one single tool that fits all the needs. I think the more tools we have available, and for this there is no extra maintenance basically. OMFIT is living already rich life and being supported. Python actors, I think we need them anyway, so it's just a coupling of those 2 approaches, which is great. I mean, it went really smooth. We had to catch the bugs because it was basically first serious usage of Python actors. Even though I did test with CPOs in and CPOs out, I did not catch this bug. Because it was just two CPOs of the same type, so equilibrium in, equilibrium out, and there was a clash of the names. And this did not happen in my test. The tests were not general enough.
Okay, so I'll be here tomorrow. If anybody is interested,
If you bring in a new actor, it automatically identifies.
So the actor is defined. So we can create a new actor like this. OMFIT actor ITM, and then I don't know, blah. Yeah. Well, right now let's put it right because I don't know what happens otherwise. CHEASE. Okay. So, oops. Yeah. Execute. Yeah. This creates an actor. So we'll look for the function, the Python wrapper called CHEASE when it wants to execute it. But if
Try changing CHEASE to was it ETS?
well, I don't have it in my thing, so it won't work for sure.
Doesn't pick it up automatically.
So it does ETS. Now, if I try to run it, it will complain. But if I had that wrapper there, it would just run it using the input CPOs. I need in my Kepler that must be compiled ETS, and there must be the Python.
You just need to have the central installation.
So if you had the central installation with the central
Exactly,
installation, bugs fixed.
That's what I'm saying.
Well,
Then
you
it's,
could have tomorrow.
yeah,
or
exactly.
maybe
Right.
Monday next week.
Fine.
So if you have a terminal, I'm sure you can import a number of actors. Maybe you need to restart OMFIT as well.
Well, I mean, you can do reload. It's okay.
But you can also list your actors. If you list the actors module, you will
From actors, or yeah, what do you mean, like dear?
just import actors and all your other actors.
Not every actor has a wrapper.
Yeah, so I have CHEASE, and this EQU to this, EQ to this, param. I don't know what these do.
And this one was fixed by.
I think the important next step would be to make sure that the next ETS we generate has the bug fixes in, so that you can then find the next set of bugs.
That's why I would like, someone also, because yeah, I'm I have a lot of other, things that I've been devoting my time with. So, I'd like to plant the seed, but, then it's up to you to pick it up. Okay. Good. Yeah, you're welcome.